systems of nonlinear equations. So up to now, we've just looked at systems of linear equations. So, for example, here we have a system that is a circle and a parabola. So these are nonlinear systems. And I'm going to solve this same system two different ways. First, I'm going to use substitution, and then I'm going to solve the same system using elimination. So the same methods that we use for linear systems can be used on nonlinear systems. So for substitution, to me, it's easiest if we have a variable that is non-quadratic. So in this second equation, I have x squared minus y equals 7, and I'm going to get the y by itself, the non-quadratic variable by itself. I'm going to subtract x squared from both sides, so the opposite of y equals 7 minus x squared. I'm going to divide everywhere by -1, and y equals -7 plus x squared, or x squared minus 7. And now we're going to substitute that in for y in the other equation. So substituting in, we get x squared plus x squared minus 7, quantity squared, equals 13. So now I need to square x squared minus 7. I need to distribute or FOIL that out. So that becomes x squared plus x to the 4th minus 14x squared plus 49 equals 13. I'm going to combine like terms. I have x to the 4th, and then x squared minus 14x squared is -13x squared plus 49 equals 13. Going to subtract 13 from both sides, and we get x to the 4th minus 13x squared plus 36 equals 0. Now this is an equation of quadratic form, so I'm going to use u substitution. U equals x squared, u squared equals x to the 4th. Substituting in, we get u squared minus 13u plus 36 equals 0. I can factor this. U minus 9 times u minus 4 equals 0. I'm going to set each factor equal to 0, so u minus 9 equals 0, or u minus 4 equals 0. Solving for u, I get u equals 9, or u equals 4. But now we need to remember u equals x squared, so let's substitute back in. We get x squared equals 9, or x squared equals 4. So solving, we need to take the square root of both sides, which means that x equals positive or -3, or x equals positive or -2. So we have 4 possible values for x. It means we have at least 4 different solutions. So we're going to use our values of x, and we're going to substitute it into this equation, y equals -7 plus x squared, to find the corresponding y values. So when x equals 3, if we're using y equals -7 plus x squared, we'll substitute in 3 for x. So -7 plus 3 squared equals -7 plus 9, or 2. That means we have one solution that is x is 3, y is 2, or the ordered pair 3, 2. If x is -3, we'll do the same thing. Substituting in -3 for x, parentheses are important, get -7 plus -3 in parentheses squared, -7 plus 9, or 2 again. So now we have the solution -3, 2. If x is 2, we're going to use y equals -7 plus x squared again. Substituting in 2 for x, we get -7 plus 2 squared, or -7 plus 4, which is -3. So now we have the third solution to -3. And our final x value was -2. Substituting in, we get y equals -7 plus -2 in parentheses squared, or -7 plus 4, again -3. So our final solution is -2, -3. So we have 4 solutions: 3, 2, -3, 2, 2, -3, -2, -3. Okay, we're going to solve the same system using the process of elimination. So here we want to choose a variable to eliminate. So y's would not be the easiest because we have one quadratic and one linear term with the y's. So here the easiest variable expression or term to eliminate would be the x squares. And I'm going to multiply my whole second equation by -1. So negative x squared plus y equals -7. And then I'm going to add the equations together. Here my x squares cancel out. I can't combine y squared and y, so I have y squared plus y equals 6. Okay, this looks like a quadratic equation. I'm going to subtract 6 from both sides. I have y squared plus y minus 6 equals 0. Going to factor this, so y plus 3 times y minus 2 equals 0. Set each factor equal to 0, so y plus 3 equals 0, or y minus 2 equals 0. Solving for y, we get y equals -3, or y equals 2. Okay, so if y equals -3, we're going to choose one of our equations and substitute that in and find our x value. I'm going to use our original second equation. So x squared minus y equals 7. Substituting in, I get x squared minus -3 equals 7, or x squared plus 3 equals 7. Subtracting 3, I get x squared equals 4. Taking the square root of both sides, x equals plus or minus 2. So we just found two different solutions here. We know that x can be positive 2 when our y is -3, and x can equal -2 when our y is -3. Okay, now our other possible y value is 2. So we already found the x values for y equals -3. Now we're looking at when y is 2. I'm going to use the same second original equation, x squared minus y equals 7. I'll substitute in x squared minus 2 equals 7. Add 2, I get x squared equals 9, or x equals plus or minus 3. So here, when x is positive 3, we know y is 2, and when x is -3, we know y is 2. So again, we have 4 solutions, the same 4 solutions we had solving it using substitution. So we have 2, -3, -2, -3, 3, 2, and -3, 2.